So yeah, I'm drinking that Coca-Cola so that I don't pass out live. Now, why, you might ask? Well, my school does trimesters instead of semesters. So essentially, instead of, well, just 2 stressful periods, we get, now you might think 3, but no, because we also have midterms at the normal time, so 4. So we get double the amount of stressful periods in the year, but it does come with the advantage of trimester courses for electives, so you get to do 3 fun courses that are, in addition to, like, your core classes. That's kind of nice. I do like trimesters for that reason. But other than that, they kind of suck. They were a lot better in, like, middle school. Anyway, we had the end of the try, which I was sick during. Then I went on a day-long camping trip, an hour both ways, but it was just really long for one day. Then I came back and had, like, 2 hours before my orchestra concert, even though I got no sleep while camping. And now it's a new try, so things have settled down and I can do this. So this is from the TXML. Now, you might be thinking, what is the TXML? Well, I'm wondering the exact same thing. Because apparently it stands for Texas Mathematics League, but no matter how deep into the internet I search, I can never find a website or anything that says TXML. I'm kind of starting to think the school made up. Anyway, you might be like, oh, Texas Mathematics League? Texas? I mean, the man who knew infinity wasn't exactly from El Paso, Texas. And you're not wrong, but looking at this actually is difficult enough to be fun. And if you see me scratching my legs, it's because they're all bloodied from camping and me scratching spider bites and stuff like that. Now we're looking for pairs of x and y that satisfy this equation, and if you're mathematically inclined, looking at this, you should immediately be able to see that xy equals 0, 0 is a solution, because 0, 22, 0, 25, is just going to be 0 equals 0. So we immediately have one solution, but obviously if this was the only solution, there wouldn't be a video, because you could just eyeball it. Here's what we're going to do. Notice that this right here and this right here are complex conjugates. So let's label this as z and this as z with a little line on top of it. So this new thing that we see is z to the 2025 is going to be equal to z line to the 2026. Now, you're thinking, well, this doesn't change anything. No, it doesn't. It just makes our lives neater, and we'll be able to do something since we notice these are complex conjugates. So, keep in mind that any complex number and its conjugate can be written in the form r times e to the I theta and r times e to the negative I theta, respectively. Gosh darn it. Alright, so we have r times e to the I times theta to the power of 2025. Now, why do math contests insist on making every large number the current year or the next lowest integer? I don't know why they do that. That kind of annoys me. And anyway, we can just distribute the exponents, so we get r to the 2025 times e to the 2025 I theta. Now we can do a classic complex number trick, and we can compare these magnitudes right here. So let's write this as r to the 2025 is going to be equal to r to the 2026. Now, since we already did our 0 case, we made the assumption that r is greater than 0 here, because z is greater than 0. We need a radius for that. Looking at this, we can divide by r to the 2025, and we get that the radius is equal to 1. And we can plug this back into our original equation, and you actually see things coming together, because 1 to any power is just going to be 1. So we get e to the 2025 I theta is going to be equal to r to the, e to the negative 2026 I theta. And now we can move everything over to one side, and we get that e to the power of 2025 plus 2026 I theta is equal to 1. Now I did kind of skip the step with theta being in here, but that's okay, it just distributes. You could factor it out anyway. I'm sure this shouldn't have confused anyone if you've been following so far. If it did, my apologies. I was not trying to be confusing. Anyway, now we get e to the 4051 I theta is equal to 1. Now here's where things get interesting. E to the power of I times phi is equal to 1 only holds if phi is equal to 2k pi, with k element of the integers. And we can apply that here, and since our angle here is 4051 theta, we know that 4051 theta is going to be equal to 2k pi. And we can divide both sides by 4051, and we get that theta is going to be equal to 2k pi over 4051, for k is an integer. So this on the contest, I actually stopped here. I forgot to actually write out the answer in the original form, which is why I did not get this right, which is unfortunate considering that I'd done all the hard stuff. This is actually just an easy part that for some reason I didn't do, which is just wonderful. Anyway, we have our basically trivial solution right here. And what we can do is now we want to rewrite this in terms of x and y like we normally did. So this does not answer the question. We got theta, but here's the thing. X is equal to the cosine of theta, and y is going to be equal to the sine of theta. So we get a bunch of combinations here where xy is going to be equal to the cosine of 2k pi over 4051, and y is equal to the sine of 2k pi over 4051. We get all of these solutions here, along with x comma y equals 0, 0. So this here combined is our fun little solution set. Don't know what that last line was. Anyway, thanks for watching. See ya.